Hi everyone, Tom from Ignite here. On this video, I'm going to talk through Servo Link, what it does, how it works in our control ecosystem, and some of the other use cases you may find for it. First of all, you might ask, why did we make Servo Link? Well, when we made Control Deck, Fusion Hub, and the whole control ecosystem, we had customers who really love zoom lenses on cable cams, things like that, and they were able to use them through nucleus motors, but obviously that adds a lot of guff, rods, you got motors that slip off, all of those kind of things. And Fujinon and Canon both made beautiful cine servo and 2/3" broadcast servo lenses. It was a logical step for us to include something to be able to control them via DJI Transmission with Control Deck, with the Tilta hand unit, etc. It was essentially a hole in our ecosystem we wanted to fill. So how does Servo Link work? Well, we take the 7-pin LEMO here, and that's Tilta input. So Tilta FIZ positional data goes in, focus iris zoom, gets converted, and then out the 9-pin LEMO and into the 20-pin or 10-pin Hirose serial port on the servo lenses. So here you can see the setup on the DJI Transmission video transmitter. We've got Fusion Hub up here, we've got the 7-pin with the Onglissimo right angle here into the Servo Link. So that is sending power to power the Servo Link and also data. You can see down the side here, we've got the 6-pin, which is joining the Fusion Hub to the transmitter. So the other ports here on Fusion Hub, for those who don't have it, we've got the DC in, which is 6-pin, and that does CAN bus. So for this Ronin setup, I've got one cable between the gimbal and this, which is doing power and data. I've also got the MōVI Pro and XL serial port. So that's a 5-pin LEMO, and that's what's controlling this gimbal out of here. And it also does the Torq head and base cam systems. One of the design challenges, similar to Fusion Hub, was to try and fit it onto the transmitter and allow room for all the plugs here on the Fusion Hub, while also having the plugs out the side. So it was a good design challenge, both from an electronics and a physical machining point of view. But we've used captive M4s. We know everyone loves captive. So you can see here it follows the exact profile of the transmitter, which makes for a neat package. A lot of you may be familiar with the 20-pin Hirose, which is standard across the Fujinon and the Canon lenses. Unfortunately, these two are not friends, and so they actually wired them differently. So it's very important, and it's the reason that we have a Fujinon and a Canon pack. They're not interchangeable. It's very important you do not use the Fujinon cable on the Canon lens, and we've marked them with the brand name on the cable ends so that you can't mix it up. We've even put a nice clear warning on the Fujinon cable pack. There is also a 10-pin Hirose, which is used on specific Fujinon lenses, and the complete pack comes with those as well. To check out lens compatibility, you can look at the Servo Link store page or the wiki. Next up, I'm just going to talk through the two rigs. So I've got the Fujinon Cabrio 20-120. This is a T3.5 Super 35 lens. I've got the old trusty Alexa Mini. I'll spin around here. I've got tilt offsets, TV50s, accessory mounts with a bit of counterweight because this lens is quite heavy. You can see I've got the DJI transmitter down the side here. Got Fusion Hub, got Servo Link here. The servos can provide a bit of a challenge in terms of gimbal builds. So I've put everything down the same side in terms of the transmitter so that the overall build is not too wide, because you can see I'm like right up against it on this side. And then I've put the majority of the counterweight on this side as well, just to offset the body being so far to the op side. So in terms of the lens power, this camera isn't powering the lens. We're powering it through our splitter Fujinon cable. And the reason we had to make this splitter cable is that a lot of the Cabrios only had one 20-pin. The Cine Servo over here has 3. You can see I've got 2 cables coming out of this one 20-pin Hirose. One of those cables is going down here to the accessory DTAP. That's putting 12 volt into the lens. And then the other one is going out of the 9-pin servo down here into there and doing control from Servo Link. So I'll show you that port there. And now let's have a look at the Ronin 2 with the Komodo. So I've got this actually controlled from the Control Deck. Komodo OG Stormtrooper, original. Still in pretty good nick, actually. Got the keystone, top plate B, gimbal mate down the bottom. And then in terms of come around this way, you've got the video transmitter on this side. You can't see it, but the Servo Link and the Fusion Hub, which I showed you before. I've got one counterweight here, and that's just to balance it up. This camera is, so again, you can see I've had to slide the camera all the way across here so that I can get the servo actually inside the cage. Another option would be to add more counterweight and have the servo outside of the cage, but I opted for a lighter rig. In terms of cabling, this Canon lens has a 12 pin, and then I've got a D-tap, I've got an IDX cable running here, D-tap to 12 pin Hirose, so that's powering the lens. So I've got 3 20-pin Hiroses under the servo here, and we're using the middle one, which is called remote or virtual, and that's the serial control port. Hiding in here is the red electronic ND RF to PL mount. And the cool thing about this mount is it does have the pins for the lens. So we're actually getting metadata back from the lens. So I can see focal length, I can see T-stop on my overlays here, and run stop works straight through the lens mount. I don't need a separate cable. The 17 to 120 gives you that little bit wider reach than the 20 to 120, and it's a really great lens on the Komodo, really great coverage of the sensor. As you can see here in this build, I don't have the arms fully extended, so there is scope for a larger camera behind this lens. I've really enjoyed using the 17 to 120. It's a really great range, and I think, you know, as far as usable on a gimbal, that's pretty much covers it. You know, anything longer than that, you start to get into, you know, GSS, shot over, or even MōVI carbon sort of focal length. I know some of you watching this video wondering, why doesn't he have a lens spot? And it's true, I don't have a lens support on this camera, but I do on this camera. The Komodo definitely needs a lot more support, and I've got both lens adapter support and the 80mm lens support under the lens foot. If I was using this setup on a black arm or something like that, I would definitely put a lens support on. I just thought, while I'm here, it's nice and clean and shows what you can do for a lot of shoots. Calling out the haters. I know you're watching Keaton. In this next section, we're going to get our hands dirty with Control Deck, Fusion Hub, and the Servo Link. For those who haven't seen Control Deck before, we have a zoom rocker down the side, focus wheel here, iris above here, and we have the joystick, which has a twist function, which could be zoom, depending on how you map it. I won't go into all the other details because there is a video for that, but we will use some of the other functions during this process, and I'll talk through them as we go. In shot, we have our lovely beer fridge with many of your stickers. Thanks for sharing. If you've got any more stickers, we do have some more room. We have another fridge as well. I'm zoomed in at 120mm. So this is the overlay that I was showing you that the Komodo is getting because of the electronic PL mount over the Cook eye data. We're getting 120mm, T4 and 1/10, very specific. So let's go T4 just because we like that. And I've got zoom mapped to the rocker down the side here. And then I've got smoothness, deadband, and adjusted for how I like it. Let's reveal our lunchroom. So I'm zooming out and I'll speed up a little bit. The zoom on these servos is always very fast. So I've got this on slow and I'm not even at full speed now. So you can see here, that's my office full of camera gear. And so you can see it's a nice smooth zoom. It's a rate-based zoom with Fusion Hub. It's like using your zoom demand from Canon. So with that data, going back to Servo Link and Fusion Hub, we're able to do zoom scaling. So in the menu, you'll be able to go down and there's a lot of different functions, but one of them is PTR/zoom ratio or zoom scaling, depending on how you like to call it. We have all the way from 1 to 1, which is just linear. So as you zoom in, the speed doesn't change. It's just, so it'll get, essentially it'll feel faster as you zoom in. And then on this lens, I'm gonna use 7 to 1, but we can go all the way up to 25 to 1, which, you know, makes sense if you're using a 25 times zoom, or if you really like it to slow right down when you're at the end focal length. So let's go back to 7 to 1, because this is a 7 to 1 lens. So what that does is, as we're zooming in, all the speeds of the pan and tilt and roll are scaling down with it. So essentially, once you're panning at that speed and you start zooming in, that pan won't speed up. It'll just stay the constant speed for that focal length. So again, let's go back to our fridge. So I'm going to start at this pace, and then I'm going to start zooming out. I'm going to zoom out faster, but you can see the actual pan feels the same speed. There you can see our CMM room and some storage. So this is a really important feature that people have been asking for, and this feature works with the Servo Link or works with the Nucleus motors, so the Nano 2, Nucleus M1 and Nucleus M2. Next feature we've got in the menu is focus curve. So similar, again, on the focus demands that you would have used, you used to have a standard and far, so that would give you more range at the far distances. So we've kind of done it slightly differently. We've done 25, 50 and 75%. And we've done that because depending on the Servo Link or whether it's a motor, like a Nucleus motor, it may be that one end is far and the other end is far on a different lens, depending on a bunch of different things. Anyway, 50% is linear, so there's no curve applied to offset the focus one way or the other. 75 is a curve like that, and 25 is a curve like that. So basically the midpoint of this focus knob, which is about there, where is that on the lens? Is it at 75%? Is it at exactly center on the focus of the lens? Or is it at 25% of the lens? So that's the ratio. So what that means is if you're doing a lot of work that's at the far end of the lens, you can offset it, and then you get more finesse on this wheel for that range. So that's a nice little feature as well. So in here on the focus menu, Fusion Focus, we've got direction, so we can adjust the direction of this wheel relative to the focus. The torque setting doesn't affect the servo lenses, that's more for the tilter motors. Next one down, Fusion Iris, again we've got direction, so if you want it to be back to the other way, and torque, again, doesn't affect this. Fusion Zoom A, direction, and then torque, again, doesn't do anything. Next one is speed and damping. So speed is the maximum speed. So I've got it on low at the moment, and you can see that's, let me show you that. So that's, let's zoom in on that knob, righto. Zoomed out, so that's, and that's high. So you can see zoom is pretty fast on these servos. So I don't really want any faster than that. Damping is the in and out finesse. What we would call smoothing on gimbal. MōVI motor type, that's not applicable here. Iris controller, it's not applicable here. FIZ handoff. So FIZ handoff is in regards to FIZBUSTER, and that's a function that is integrated into this control deck. So since serial number 100 and above, we've integrated the 7-pin LEMO here at the back, and I'll just grab the FIZBUSTER and show you how that works. We created FIZBUSTER to solve the problem of operators wanting to hand off either all of the FIZ functions or certain axes. Because we're using the Nucleus motors, it made sense to use the Nucleus M1 and M2 hand units for this function. So basically you take your cable, 7-pin cable, we include this with the FIZBUSTER. If you buy the separate module FIZBUSTER, which is this, so if you didn't have a control deck, you had inertia wheels with the cam buster, you would use this. Or if you wanted to, say, run another DJI high-bright monitor, so this is control monitor A. If you wanted to have control monitor B way over there, you could click this onto that other monitor and plug in the hand unit. So I'm going to plug into the back because this control deck has FIZBUSTER built in. So it's the orange LEMO on the back here, and I'm just turning on the hand unit. And now in the menu, I can adjust FIZ, FI, focus and iris, just F or just I, and that's what I can choose to hand off. So if I hand off full focus, iris and zoom, whoa, you can see this is back to front. So again, the settings on here in terms of direction and stuff are what affects it. So you can set that up to different things. So you can also do run stop. which you can see here. Again, I've got FIZ now, I could just hand off focus, and then here as an operator, I can still zoom, I can still control the iris, but I can't do focus. The focus is up here. So that's a really cool feature. And again, yeah, if you were running you want to do a focus puller to have a separate monitor and be connected via DJI Transmission, the Fusion Hub can deal with the two. So you would click this FIZBUSTER, you would click onto the side of the monitor like that, and then turn this on. So FIZBUSTER does the data through, but it also powers the hand unit. Next menu function is called Servo Link, and that's important for where you're using this setup in a broadcast situation, and CCU need to have control of that lens or a 2/3" lens iris, so that they can control that and you can just focus and zoom. So that's a hard setting that changes on Servo Link, and you can see that's now changed to blue. So FZ is blue and FIZ, full control on here, is orange. So if you were doing a broadcast and CCU wanted to have iris, you would change to FZ mode. Next menu is the PTR zoom ratio or zoom scaling, which we've gone over earlier. And the last one is FIZ calibrate. So you won't need FIZ calibrate because the encoders on that already do it. So that's another nice thing about this lens, is it doesn't need to map itself. It knows where it's at. You do it once when you first plug the servo into the lens, and then you never do it again. So I'll jump back up to the top of the Control Deck menu and go through the general functions that you'll want to see. Joystick expo, so that changes the curve of the joystick, linear, squared, and cubic. We then have twist axis, so I've got that on roll at the moment, but you can disable that if you don't want anything to be on that twist. Zoom, roll, swap. So again, swap that, and now you've got zoom on here and roll on the rocker. Focus knob cal, that's to calibrate this. So if you feel like this is not actually getting end to end correctly, you can calibrate it. And I'm just calibrating now. And if it's good, it'll say complete. Roll speed, that's your maximum roll axis speed. I just run it on low because I never want to do a fast roll. Shake mode, so we have a shake function on. Let's have a look at the table turns table there. So you can see I'm adjusting there, I've got shake. Smoothness adjusts that as well. So if you want to look like, for those car shoots where you want to add action, you can just do that right here. And shake mode is the algorithm. So we have 3 different algorithms for how it moves. Shake on move is if you want it to still shake while you're panning, say, or if you don't want it to. So if you're moving an axis, you want it to just be smooth, but then as soon as you stop on that axis, it'll start to shake again. It'll ease shake back in. So that's a personal preference, really. Shake axis you can enable for each pan, tilt, and roll. So if you just want pan, you can do that. User profile, so that's R2 user profile. You can jump between the 5 profiles on here. So you could set one up to be like a follow mode. So when you're on a car rig, you can just switch to that, and then that'll just stay and people can turn around and you don't have to baby the gimbal. There is a shortcut to do that on the mode button, so you can jump between user 1 and 2 quickly there. Fusion Hub, so we want to run Fusion Hub in the menu on because we have it on. If we don't have it on, we're just running the transmitter on this Ronin setup, we would want it to be off. Up here we've got pan and tilt speed, but that's also pan and tilt recenter buttons. So tried to combine as many functions into each dial as possible. Master rate up here in the top corner is an overall adjustment of speed. So it's, yeah, like it says, master rate. So you can set your maximum speeds here and then ride that. Now that we have zoom ratio for these lenses and the nucleus motors, I think this function is less useful, but you might want to run it, say if you're running primes and you're swapping out, particularly on the Inspire 3 or something like that, you might want to just be able to quickly adjust the percentage and keep your ratio and maximum speeds the same. Another operator-friendly function is crash zoom. This mark button here on the left previously didn't do anything in a Ronin 2 or MōVI Pro setup. It was just for Inspire 3 and 4D use. So we've mapped it to crash zoom. So what is crash zoom? Basically it will zoom in the servo or the Nucleus-M Nano M2 motors to 100% and then back out to where you were previously. So when you crash zoom, it'll stay up on the screen so you know it's in crash zoom mode. So I can't zoom now, I've got it on twist, I can't zoom, but I go press there, it goes back out to where I was framed previously. So this is really helpful to be able to crash in, check focus, crash back out. So again, that's nice and close to where you're focusing. You can just quickly focus, yeah, and then crash back out. All right, let's go off gimbal, same build, Komodo 70-120 Canon, got the DJI Transmission, Fusion Hub, Servo Link. I'm powering here off the TB51 hammerhead. So dual TB51, outputs 20 to 25 volts and 15 volts. So in this case, I'm using all 15 volts. You can see I've still got the lens plugged in here, still got Fusion Hub plugged in here, and I have control from Control Deck still. I still have focus, I still have iris, and I still have, if I reach over, I've still got zoom. That's one option. You could continue to use that as your FIZ controller. I'm not sure there's that many people that would want to use that as their FIZ controller off gimbal, but you can if you want. Next option is, if you wanted to hand off the focus, is the FIZBUSTER we mentioned earlier. So that with the M1 or M2 hand unit, you would drop that on there, drop that onto the side of the monitor, either this monitor or another one connected as control monitor B. Drop it on there. Whatever I choose in the Control Deck menu, I've got handoff for. So again, that's still all connected via DJI Transmission. Next option, if you have a Control Deck that is serial number 100 or higher, you have FIZBUSTER built in the back, which we mentioned earlier. So again, plug in there, you get control, still via DJI Transmission. Let's say you're not using DJI Transmission for your video transmitter, but you still want to use Servo Link's functionality. So Servo Link, Tilta in, servo out. There's plenty of Tilta options out there in terms of lens control. So let's see how they work with Servo Link and this 70-120. First up, I'm going to unplug the lens from that Servo Link and I'm going to plug it into this Servo Link. Then I'm going to get a short 7-pin to 7-pin cable. This one's a Tilta one. And I'm going to plug that into the grip and then plug that into the Servo Link. So you can see now that powered up. I'm going to power this grip up. I've got the NPF battery in here, so that is doing 7.4 to 8 volts through, powering the Servo Link. So it's quite handy that it can run off lower voltage. And now I've got focus on the front here, and then on the rocker, on the pressure thumb pad, rocker, whatever you want to call it, I've got zoom. So that's pretty cool. If you want to change the mapping of this, just double tap menu button, scroll up, knob number. So that's going to change what motor that's mapped to. Double tap, press, and I'm going to change it. Focus iris, zoom. So let's go iris and long press. Now clear that. And now I have iris control up front. Nice smooth iris control. So this is a really simple cabled single grip solution. If you want to run both grips and have control, then it gets a little bit more complicated. So you want to unplug that. I'm going to leave this just to be wireless, and I'm going to add the Nucleus-M motor. So the M1 motor is the only one that can act as a fully wireless hub. So in that sense, I mean, it receives data wirelessly and then outputs that data on the 7-pin EXTs. In theory, the M2 motor should do this, but in practice, it doesn't. It will pass through data it receives on the cable in here and pass it out there, but if it receives data wirelessly, it doesn't pass on either port. So we've been in touch with Tilta and are hoping that they will fix that in the next firmware update. So currently get your old M1 motors out for this configuration. All right, MōVI magic. So Nucleus-M motor, and I've got short cable to the Servo Link, Servo Link's cable to the lens, and then this cable, which is right at the end of its length, is a 2-pin to 7-pin going from the power break out underneath, which is fed by the TB51 hammerhead. So power into the motor, power and data out to the Servo Link, and then data out to the lens. So I've got my grip here, I've got iris, I've got the pressure pad for zoom, and then on this side, I don't actually have an MPF, so I can't power this grip, but I would map focus, so motor 1 on this side. Then you got full FIZ on the grips for a servo lens on your shoulder. I mean, this is made for your hand, but sometimes you want to operate more like this or on an easy rig or things like that. So the next stage would be to involve this guy. So the way to do that is you would connect this via the 2.4 gigahertz link, Tilta links on the same channel, and then you would map this to the channel you want to control here, say focus, map 1 in to the focus knob, and then on here you would map the other axes to nothing. And then on here you would map iris and zoom, say, and then on this side map nothing, so that you're not both controlling focus. You've got to be careful with Tilta stuff that you don't map two things to do the same function, otherwise the lens will be going back and forth because they'll be fighting, because it is absolute based. So it's 0 to 9,999 position. One other detail I forgot is that this motor I have mapped to be motor 4. So that means that I'm not controlling anything on it. So 1, 2, 3, focus iris zoom. Motor 4 is there as a choice for like a Varian D or something. That's why Tilta put that channel in there. But we're just using that so that we don't have that ripping around back and forth because that's just a wireless hub. So obviously I feel like I would mount that better. It does use M4s. It's not a standard spacing, so it's a little bit awkward. Maybe we need to make a little cheese plate for it. But currently everyone's using it with Fusion Hub, so there hasn't been a need. All right, I've put the MPF into the hand unit, the M2 hand unit, just booting up. And now you can see here, I've got focus, I've got zoom, I put onto this, which is the dial. It's not great for smooth zooms, but it's handy for reframing. And then iris down the backside, the slider. So I've actually pre-mapped this lens, which is cool. So the M2 hand unit has lens mapping. So you can actually see the focus distance here. You can see the iris, and you can see the focal length in millimeters there as well, changing. This pressure pad zoom rocker, well, it's definitely not a rocker, it's a pressure pad. This pressure pad is a little bit finicky. I've had some issues where it sort of drifts. It's like it's pressuring itself. I may have pushed it too hard. You definitely need to be careful with it though. So I would map zoom to this here. So that gives you a look at how the Nucleus M1 and M2 kits can work with Servo Link, regardless of Fusion Hub and the DJI Transmission system. So in terms of the link range between this and the motor, Tilta say up to 1,000 foot, so up to 330 meters or so at maximum. It is 2.4 gigahertz, so it is a pretty busy spectrum. Whatever you're used to getting with your Nucleus, you'll still get with this setup. You'll just be able to control servo lenses. If you have the advanced grip for the RS gimbals from Tilta, these hand grips on the side, you've got 3 knobs, so you can actually do focus, iris and zoom with a servo lens in a similar way to this build here, and you can still have joystick control for the gimbal here. I haven't got the Canon 24 to 105 RF zoom, which we've been playing around with for the last few weeks. Unfortunately, it had to go back to Canon. That lens has a module that has a 20-pin Hirose and allows you to control that lens in a similar way to the bigger broadcast and cine servo lenses. So that does work with Servo Link, and it does balance with a C50 or a Komodo X on a build like this. So there is scope for you to use Servo Link to allow you to have focus, iris and zoom on here. You would do that by a similar build to here, where you're using the Nucleus M1 motor mounted somewhere here on camera as the wireless receiver. So you would maybe map that to channel 2, map these to channel 2 as well on the wireless, and then you could map each of these to focus, iris and zoom. And that motor, again, would pass the data to Servo Link, and the Servo Link would pass it to the Canon 24 to 105 with the servo module. There are some other products on the market that control Tilta Nucleus motors. One of them is the eMotimo Conductor. So that is a box that controls both the RS gimbals and Nucleus motors and allows you to set up a sort of PTZ-like Dana Dolly combo single shooter setup. It's very cool, and being able to use the Tilta motors has been great, but now opening that up to using the servo lenses is also very cool. Next up, I just want to show you a quick build on the NODO Torq head. We showed this with the Venice on it at Cine this year. Our good friends at NODO have been working on this head for a while now. We've been working on camera plates, battery solutions, that kind of thing. And the next evolution was to be able to control it via the Fusion Hub. So here we have DJI Transmission, we have the Fusion Hub and Servo Link hiding on this side. It's in that configuration to balance the roll motor, which is the innermost here. And I also have a counterweight on this side, which you can see, and that's helping to offset the servo and the transmission to make it nice and balanced on the roll axis. I've got a P70 here. This is one of the older, small Sony box cameras. These are prototype plates, 3D printed, and then spacers. So the spacers are required because the P70 and the P1, the older ones, are 130 high, and the newer P50 and that kind of thing are 140 high. So they're 5mm spacers and then a top and bottom plate that will come as a kit. Anyway, I just wanted to show this build because it is a very interesting head for broadcast and other servo lens applications like wildlife or vehicle tracking. So yeah, that was why I wanted to mention it. And thanks to Canon Australia for the loan of this wide angle. Servo Link and all of the products in the Control ecosystem are a long-term collaboration between Ignite Digi and Signal Audio. Signal Audio is our good mate Tad Airy, based in Melbourne. He's a programming wizard that has enabled the DJI Transmission to work with the Nucleus-M, with the Ronin, with the MōVI, all of the different things. So thanks, shout out to Tad for all his work on this. Thanks for tuning in to the end. If you've got any specific questions about how the ecosystem works, then check out the wiki linked below. We're really excited for Servo Link, which is available now, to head out to the world, sports, live events like music festivals. It's going to be awesome. Have fun shooting out there and see you next time.